In a black and white survey photograph from the late 19th century, a ridge rises out of morning fog, like the broken rim of something enormous. At first glance, it looks familiar: timber, slope, cloud, distance. Then the scale begins to fail. Tiny men stand near the edge with axes and measuring poles, and the ridge behind them does not behave like a ridge at all. It curves too cleanly. It lifts in a ring. Its walls are fibrous in places, vertically fluted, strangely regular, as if the mountain had not been pushed up from below but cut down from above. The trees around it look small, recent, temporary. The land behind it looks older than the map meant to describe it. So what are we really looking at when a mountain resembles a stump and a stump resembles a mountain? The accepted explanation is simple enough. Mountains are products of uplift, erosion, volcanic intrusion, sediment, glaciation, and time measured in spans no human mind can picture directly. Plate boundaries rise, lava cools, rivers carve, ice scrapes, wind removes, forests come later, taking root in whatever geology leaves behind. In this reading, the resemblance between some mountains and cut wood is coincidence, a trick of pattern recognition. Flat-topped formations are mesas, columnar walls are basalt, concentric ridges are ancient calderas, domes, laccoliths, or deeply eroded intrusions. The historical record of logging, meanwhile, is well documented, but finite. Tall trees, yes. Giant forests, yes. Species now rare, yes. Yet always within a recognizable biological range. That is the official explanation. And for most landscapes, it works well enough. But there is a problem with explanations that work well enough. They often stop exactly where the uncomfortable details begin, because there are places where the terrain looks less like broken rock than worked fiber. There are slopes that peel. There are cliff faces marked by parallel vertical grooves too evenly spaced to feel accidental, and summit rings that resemble cut collars rather than natural rims. There are old photographs in which felled trunks dwarf horse teams, cabins, and railcars to a degree that already strains modern expectation. There are logging reports that describe timber so large it was processed in sections, burned where it fell, or simply abandoned because no mill could use it. And there are names in the record: Stump Meadow, Log Hill, Sword Mountain, Petrified Forest, not proof by themselves, but clues that earlier observers sometimes described the land with a language geology later discarded. The hidden theory, stated carefully, is not that every mountain is a tree stump or that all geology is a deception. It is narrower, stranger, and harder to dismiss cleanly. It suggests that some landforms now classified as purely geologic may be the mineralized or transformed remains of an older biological world, one that included arboreal structures far larger than anything recognized by modern botany. Over immense time, under pressure, heat, silica-rich water, volcanic ash, and repeated burial, those structures may have hardened, altered, fractured, and been reclassified as stone. In that view, what survives is not the tree as we understand a tree, but its geometry, its grain, its radial pattern, its sheer scale. Not living wood, but at a record in mineral form, the stone remembers, must begin with shape, because shape is the first thing that makes this theory difficult to forget. Across several continents there are isolated flat-topped heights, with steep sides and surprisingly circular or elliptical outlines. Some have radial drainage patterns running outward like cracks from a centre. Some show outer bands, terraces, or shelf-like rings that resemble growth layers more than stratified slopes. Standard geology can explain many of these features individually. Erosion isolates plateaus. Hard caprock protects summits. Jointing produces columns. But what remains when multiple wood-like features occur together, circular perimeter, central depression, fibrous weathering, radial cracking, ring benches, and surrounding fields of smaller, younger growth? The question is not whether one feature can be explained. It usually can. The question is why the same visual grammar repeats. If a botanist found a fossil leaf with clear venation, margin, and stem attachment, classification would begin with morphology. Yet when a landform shows the geometry of a cut trunk at a scale too large to fit accepted categories, morphology is suddenly treated as a trap. Then there are the vertical walls. In ordinary forests, a stump reveals grain, cambium, tearing, compression, asymmetry from growth conditions, insect damage, fire scarring, and the rough violence of decay. On a far larger scale, some cliffs appear to preserve something disturbingly similar: long vertical striations, bundled textures, and outward flaring buttress forms near the base. Our geological literature describes these patterns as cooling joints, exfoliation, weathering bands, and differential erosion. Fair enough, but cooling joints in igneous rock typically follow thermal stress patterns and fracture mechanics that geologists can model. What draws attention here is how often the surface texture evokes organized bundles rather than merely broken columns. In aerial images, certain escarpments do not look assembled from blocks. They look shredded. They look cut. Some even seem to show a slight twist, as if growth once followed a spiral load path now frozen into stone. It is possible, of course, that human perception is simply too eager to find wood in rock, but it is equally possible that modern categories are too eager to prevent the comparison from even being tested. Whilst old photographs make the argument more unsettling because they do not begin with mountains, they begin with trees we know existed. 19th century logging archives are full of images dismissed today as exaggeration or trick photography until the negatives are checked, the shadows measured, and the machinery identified. Men posed atop trunks wider than a room. Platforms were built directly onto cut surfaces. Cross-sections were large enough to host multiple workers at once. Railroad flat cars vanished beside sections of timber. Not every image is reliable. Some were staged, some cropped, some proudly promotional. Still, a substantial number are authentic, and they document forests already at the outer edge of accepted scale. Once that is admitted, a more difficult question enters. If industrial logging encountered living organisms that large within the narrow window of modern recording, what had existed before that window, in climates, ecologies, and atmospheric conditions not fully recovered? The official answer is that species size has limits, and those limits are known. But the fossil record is biased toward what preserves, what is recognized, and what institutions are prepared to call biological. Mainstream geology deserves a fair hearing here, because many claims built around giant tree theories collapse under basic scrutiny. Basalt columns do not require wood to form. Buttes and mesas do not need an organic origin. Petrified wood exists, but it is usually measured in logs, not mountains. Concentric landforms can emerge through volcanism, doming, erosion, and collapse. Human beings are also famously poor at scale, especially when faced with aerial imagery. All of that is true, and any serious investigation has to say it plainly. The problem is that these explanations often work one feature at a time, while ignoring the cumulative anomaly. They explain the flat top, but not the fibre-like sidewall, the columns but not the ring but not the radial cracking, but not the local naming tradition, the naming tradition, but not the archival photographs of nearby oversized timber. The official explanation is strongest in pieces. The theory gains force in clusters. What matters is not a single resemblance, but a stack of them appearing in the same place. Measurements matter too. When a stump is cut, the proportions between diameter, outer taper, exposed surface, height and root flare follow structural rules, especially in organisms built to carry load and resist wind. Very large trees broaden at the base, not randomly, but according to stress. Some mountains that attract this theory show exactly the kind of lower massing one would expect from a rooted columnar organism, an abrupt widening into ridged buttresses, then a comparatively straighter rise into a cut-looking crown. In some cases, the summit plateau occupies a diameter disproportionately wide relative to the supporting trunk, as if the upper mass once spread farther before removal. Again, geology can reply with erosion-resistant caprock above softer material, and often that is enough, but not always. Some supposed caprock layers do not sit as simple blankets, they arch, split and curl. Some slopes display arc-like bands, where one might expect growth stress, not deposition. If these are only rocks, they are rocks that repeatedly imitate biological engineering. Maps add another layer, because maps preserve older eyes. Early survey sheets, military route maps, timber concession maps, and land patents sometimes record a landscape before later standardization cleaned up its language. One region calls a formation table stump, another marks petrified ridge, long before any protected fossil site is declared. There are parcels named for burned stubs, giant roots, stone wood, or sword tops in places where the current geological description avoids all such terms. Most names are rough folklore, not formal evidence. Yet naming is never meaningless. A name is an impression stabilized on paper. If multiple generations of surveyors, hard settlers or local workers described a formation with arboreal language before geologists fixed a different interpretation, that shift deserves attention. What changed was the explanation. The record is still there. Even legal descriptions can be revealing, especially when a land parcel is bounded not by a creek or ridge, but by a stone stump, a great snag, or a charred stand, now regarded as metaphorical. Was it metaphor, or was it observation later made embarrassing by scale? There is also the question of what is missing. If a mountain is a mountain in the ordinary sense, the surrounding geology usually tells a coherent story about how it formed. There should be parent material, debris fields, erosional context, matching strata, feeder dikes, volcanic ejecta, glacial signatures, and/or regional structures that make the landform legible as part of a system. Yet some isolated formations feel strangely disconnected from their surroundings. They rise abruptly from terrain that does not seem to explain them. Their stone differs from nearby bedrock. Their fractures do not align with regional tectonics. Their slopes shed unusual blocks, slabs, or crumbly fibrous rubble that locals have long described in non-geological terms. None of this proves a biological origin. But the absence of comfortable context matters. In any investigation, anomalies cluster not only around what is present, but around what should be there and is not. Missing infrastructure, missing continuity, missing explanation. At this point, the theory widens beyond a single mountain or photograph. The pattern repeats across categories. There are giant stumps proposed in North America, Europe, Asia, Africa, and Australia. There are ridges interpreted as fallen trunks, branching canyon systems read as root systems, eroded domes that resemble knotted burls, and stone forests whose accepted description as mineral replacement only deepens the biological question rather than closing it. There are plateaus bordered by near vertical walls that look cut to a common height, as if a larger event removed upper growth across a region. There are old clearings where no corresponding logging infrastructure survives, despite local legends of timber extraction on a scale that should have left roads, camps, mills, spoil heaps, iron hardware, and payroll records in abundance. Either the stories exaggerate, or a much older episode of removal happened under conditions outside ordinary industrial history. The pattern does not disappear, it scales, and that scaling introduces time, which is where the theory becomes more serious and less theatrical. No one needs a dramatic secret society to explain why a possibility like this remains unexamined. Institutional knowledge does not hide only through conspiracy, it also hides through categories. A botanist is not trained to classify mountains. A geologist is not rewarded for calling stone biological without overwhelming evidence. An archivist catalogues a photo without revising paleobotany. A forester records stump diameters within the living range of known species because anything beyond that range is assumed to be error. Universities protect their disciplines the way organisms protect tissue. Funding follows accepted questions. Museums label specimens according to current consensus. Bureaucracy smooths anomalies by routing them into familiar boxes. Classification itself can bury an idea more effectively than censorship. There is no need to forbid the question if every profession is arranged to find it illegible. Consider petrification, because this is the bridge between the impossible and the merely neglected. We know wood can become stone. Mineral replacement is not speculative. Silica-rich water can infiltrate buried timber, preserve cellular structure, and create fossils that still display bark, rings, knots, and grain under a microscope. The official explanation accepts this completely, up to a point. The limit appears not in the mechanism, but in the permitted scale. Once replacement is acknowledged, a new question follows naturally. Under what conditions could larger biological architecture mineralize while losing the fine details that would make recognition easy? Deep burial, volcanic ash, hydrothermal circulation, compression, metamorphic overprint, and immense time could preserve gross geometry while erasing the obvious microscopic markers on accessible surfaces. In that scenario, what remains at the surface might present as partly geologic, partly biological, and easy to misclassify from a distance. The difference between a fossil and a formation may be less absolute than our labels suggest. There are eyewitness descriptions too, scattered and imperfect, but persistent enough to notice. Early travellers wrote of wooded stone and trunk-like crags. Miners described cliffs that splintered oddly under blasting. While quarry workers reported layers that peeled like bark or exposed radial textures unlike the surrounding rock. Loggers spoke of ancient stubs already turned to iron-hard material, too useless to mill and too tough to remove. Most of these accounts are anecdotal. Some are almost certainly embellishments. Yet in archival work, anecdote is not worthless. It is directional. It points. It tells investigators where to look. The striking thing is not that earlier observers used the wrong language. It is that they often used a more literal language than later science allowed. They said stump because stump was what it looked like. Later writers, inheriting a narrower vocabulary of possibility, translated appearance into geology first and curiosity second. And photographs of clear-cut landscapes deepen the unease because they show something else, an industrial appetite that moved faster than classification. Entire valleys were stripped, burned, graded, and replanted within a few decades. Enormous sections of wood were left to rot, or were incinerated because transport systems could not handle them efficiently. If timber at the known upper limit was treated as nuisance material, what would happen if crews encountered remains beyond market use, beyond milling capacity, beyond ordinary terminology? They would blast, burn, bury, grade, and move on. Not out of malice, out of economics. The record of extraction is always more selective than the extraction itself. Companies recorded what could be sold. Surveyors mapped what could be taxed. The rest became overburden, waste, obstacle, or scenery. What survives in archives is rarely the full event. It is the profitable fragment. Then there is the visual similarity between some mountain systems and root flares seen from above. This is where the theory attracts ridicule, and rightly so if stated carelessly. Any branching terrain can be compared to roots because drainage networks are fractal. Rivers branch, cracks branch, roots branch. Similar shape does not prove similar origin, but in a few cases the analogy extends beyond simple branching. There is a central columnar mass, an outward buttressed base, radial ridges, descending channels that divide like load-bearing supports, and adjacent fallen linear formations aligned as if related structurally rather than randomly. One can still explain this through erosion. Often that will remain the best answer. But the comparison becomes harder to ignore when the surface textures, local fossils, circular perimeter, and historical naming all point in the same direction. Investigations fail when they mistake resemblance for proof. They also fail when they forbid resemblance from guiding inquiry at all. The strongest objection is also the most sensible one. If mountains were stumps, where are the roots, the cells, the unambiguous biological tissues, the transitional specimens that would settle the matter? It is the right objection. Any theory that cannot survive that question deserves to fail. But notice what the objection assumes. It assumes preservation should remain obvious at gigantic scale, despite heat, pressure, mineral replacement, deformation, erosion, and repeated reclassification. And it assumes sampling has been conducted with the question in mind. It assumes the correct surfaces have been drilled, the right thin sections prepared, the right chemistries compared, the right formations re-examined outside prior labels. Has that happened in any broad coordinated way, or has the theory been treated as too strange to merit the kind of testing that would either kill it properly or, more dangerously, complicate the present model? The real weakness of fringe ideas is often that they are wrong. The real weakness of institutions is that they rarely bother to prove them wrong in a way the public can inspect. What remains, then, is not certainty. It is a pattern of unresolved correspondences. A mountain that resembles a cut trunk may still be only a mountain. A ringed plateau may still be only a resistant cap. And a fibrous cliff may still be only weathered basalt or altered sediment. Yet when image after image, map after map, name after name, and record after record begin to rhyme, skepticism should not end the investigation. It should begin it. The burden of proof is real, so is the burden of curiosity. Hidden history is not always a story of lies. Sometimes it is a story of scale so large that the mind refuses the first honest comparison. Sometimes the land says one thing, the archive says another, and the institution chooses the quieter interpretation because it fits better on a plaque. Look again at the cold photograph on the ridge. The men appear tiny because they are tiny, but also because the object behind them may belong to a category the map did not know how to name. Perhaps it is only stone made dramatic by distance and fog. Perhaps that is all it ever was. But if even a small number of these formations are what the theory suggests, mineralized remnants of an arboreal world larger than accepted history permits, then the landscape has been hiding evidence in plain sight, not beneath secret vaults but under routine words, like mesa, butte, dome, and uplift. The implication would be profound, not because it would erase geology, but because it would force geology, paleobotany, forestry, and history into the same frame. The mountain would stop being only a mountain. The stump would stop being only a metaphor. And that is the final unease. The theory sounds strange because the scale is strange, but scale is exactly what old photographs, abandoned survey terms, impossible clear cuts, petrified wood, and isolated formations keep returning us to. There is the accepted story, and there is the residue left when that story passes over the land too quickly. There is the label, and there is the object beneath the label. The stone remembers. The record is still there. What changed was the explanation. The real question is not whether the theory sounds strange, but whether anyone with the tools to verify it has seriously looked